Anticonvulsant profile of the Enantiomers of DL-HEPP in vitro and in vivo study. Epilepsy is a brain disorder that causes repeated seizures and affects 1% of people worldwide. About 30% of patients do not respond well to current medications, which often have harsh side effects. This study explored a potential new treatment called DL-HEPP and its two mirror image forms, +-HEPP and -HEPP, to see if they could work better with fewer side effects. Researchers in Mexico synthesized DL-HEPP, separated it into its two enantiomers, and tested their ability to prevent seizures in mice. The compounds were checked for purity, over 99%, and tested in different seizure models, including chemical-induced and electric shock-induced seizures. They were also evaluated for brain-related side effects using a balance test, Rotarod. Results showed that DL-HEPP and both enantiomers were effective at stopping seizures without causing major side effects. In some tests, they even worked better than a common epilepsy drug, sodium valproate. Interestingly, while both forms were equally strong at their peak effect, 30 minutes after dosing, -HEPP lasted longer in the body, while +-HEPP lost its effect faster. The study suggests that DL-HEPP works by boosting the brain's natural calming system, GABA, which helps prevent seizures. Since the racemic mix, DL-HEPP, performed just as well as its separated forms, the researchers concluded that separating the enantiomers may not be necessary for future drug development. This discovery could lead to safer, more effective epilepsy treatments, especially for patients who don't respond to current medications. Further research is needed, but these findings offer hope for better seizure control with fewer side effects. Introduction. Epilepsy is a brain disorder causing recurrent seizures that affects 1% of people worldwide. While current medications help many patients, 30% still experience seizures, and even those who respond often suffer side effects. This highlights the need for better treatments. Researchers have studied a promising compound called DL-HEPP, part of a family of anticonvulsant drugs that protect against multiple seizure types in animals. DL-HEPP works by boosting the brain's calming system, GABA, and has shown low toxicity in tests. It also helps in models of epilepsy resistant to standard drugs like diazepam. This study focused on separating DL-HEPP into its two mirror image forms, enantiomers, to compare their effects. Both forms showed strong seizure protection with minimal side effects in mice. Interestingly, while their peak activity was similar, one form lasted longer in the body. DL-HEPP has already been tested in healthy volunteers, showing good absorption and safety. However, more research is needed before it can be used in patients. The findings suggest DL-HEPP could become a valuable new treatment, especially for hard-to-control epilepsy. Conclusion. At their peak effectiveness, 30 minutes after dosing, both forms of the experimental epilepsy drug DL-HEPP work equally well at stopping different types of seizures in mice, without causing extra side effects. This means scientists don't need to separate the drug into its two mirror image versions for future testing. The drug appears to work by boosting the brain's natural calming system, GABA. These findings suggest DL-HEPP could be developed as an effective epilepsy treatment without the extra step and cost of separating its components, moving it closer to potential human trials. This important article is authored by the following scientists.
Thank you for watching this video. Please subscribe to our channel BP International To watch more videos in the fields of science, technology, and medicine,